The first section of this course will discuss Boolean algebra. This is a refresher of the Boolean logic you might have studied in high school. Even if you have already studied Boolean algebra in the school, do not skip this entire section. Instead, focus on the later lessons in this section. Quantum cryptography, which is built upon simple Boolean logic and shared secret codes, are discussed in the later lessons. We will begin with Boolean logic and Boolean algebra. Most of us are familiar with the algebra of real numbers. That is, how we add, subtract, multiply, and divide real numbers. In a similar manner, Boolean logic consists of operations for logical statements. Instead of arithmetic expressions, we have Boolean statements. Boolean statements are statements that can be true or false. Instead of numbers, we have Boolean values which are true or false. Here are some sample Boolean statements. Alice owns a red car. Bob is older than 40 years. Alice ate mushrooms at dinner yesterday. We are familiar with such statements from our conversations with friends and family. These statements can be either true or false. This is important, so I will repeat that. A Boolean statement can be either true or false. No other values are possible. When we speak with our friends, we can combine these statements. We might say, Alice owns a red car and she ate mushrooms at dinner yesterday. We have combined two different ideas using the rules of English grammar. Alice owns a red car and Alice ate mushrooms at dinner yesterday. But English grammar is imprecise. For math, we need a precise grammar on how ideas are to be combined. This mathematical grammar is Boolean algebra. In Boolean algebra, ideas are combined using operators and, or, and not. These operators have a precise meaning. There is no ambiguity. Using the grammar of Boolean logic, the two ideas we discussed can be combined like this. Alice owns a red car and Alice ate mushrooms at dinner yesterday. The Boolean operator AND combines two different Boolean statements. The combination is also a Boolean statement. The combination statement can be either true or false. At this point, you might be wondering, what is the big deal? AND is an English word. Instead of writing a statement using English grammar, we have written it using a math operator called AND. The operator AND has the same meaning as the English word AND, so what? The reason we use math is that we can use math rules to manipulate expressions. In other words, after we have represented these ideas with symbols, that is, two Boolean statements connected with an AND operator, we can manipulate these Boolean expressions using a set of rules without thinking about the real-world meaning of these expressions. For arithmetic, you had rules like a times b plus c is equal to a times b plus a times c. You were able to rewrite a times b plus c as a times b plus a times c without thinking about the real-world meaning of a, b, and c. A similar set of rules for Boolean statements is called Boolean algebra.